Hello and welcome to DDD 2020. Before we start my session today, let's be aware of the code of conduct for the day. Let's follow all the full code of conduct for the day and have a pleasant, fun, knowledge-filled day for ourselves. DDD is supporting the National Museum of Computing, so feel free to donate to the museum. And a big thank you to all our sponsors this year. And should you wish to tweet something, use the hashtag DDD2020, and the Twitter handle is Developer Day. I'll be talking about components and forms in Blazor today. I'm Poornima Nayar, and I'm a freelance developer based in Langley, UK. I do a lot of work with Umbraco CMS, which is a .NET-based open source CMS, and I've been an Umbraco MVP for 2 years in running. Non-work me, I spend a lot of time with my little girl who's 6-year-old. I spend a lot of time reading, mainly fiction. And in my free time, I also learn Carnatic music. So you'll find me perfecting all the notes in my compositions. And that's my Twitter handle should you wish to connect with me on Twitter. Today's topic is components and forms in Blazor. I haven't personally done any project work on Blazor. So it's basically sharing the knowledge of what I know about components and forms in Blazor. Components are building blocks of Blazor apps. They are Razor files with a .razor extension and are formally called Razor components. They can be a page, a form, or a dialog in your app. And when I say that components are everywhere, I literally mean it. They are everywhere. Everywhere in a Blazor app, you would find a component. There are certain conventions on how you name your component. Your Razor component must always start with an uppercase character. If you have a component called myComponent.razor, you can include that in another component by using the name of the component as the HTML tag, as I show here. You have the ability to nest components. Components can be reused. You can share components amongst projects. There's the concept of component libraries if you're interested, where you can create little libraries of Razor components and then you get it up and share it across your projects, or even open source it and put it outside to the world for you. Let's talk about C# code in Razor components. So C# code is supported in Razor components. That's what Blazor is all about, running C# on the browser. So there are 3 ways of including C# code in your Razor components. The first one, or the first approach, is the code directive approach, in which my Razor markup as well as C# code coexist in a single file. As you can see, there's a component called code directive demo, and I've got my C# code inside a code directive. So inside the code directive, I can have fields, properties, any C# code that I basically want for my component, and that gets picked up perfectly. The second way, or the second approach, is using a partial class. Razor components, when built and compiled, give rise to partial classes behind the scene, public partial classes. So you can create a partial class of the same name as your Razor component and put your C# code in there. The most important thing is your partial class must be a public partial class, which is of the same name as the Razor component here. And as you can see, it's the same exact code that I've got here, which I've split it up into 2 different files. There's a third approach as well, which is using a base class. So in this method, you still have a Razor component with your Razor markup. And as you can see, again, it's the same code. I've got something extra in here because I was playing around with it. But I also define a public class of some name. It need not be the same name as my Razor component, and inherit from the component base class. So the component base is the optional base class for components. So if you want to create a Razor component or any component as you would see going ahead, it needs to inherit from the component base class. And I can put my code in there. And back to my Razor file, I need to inherit from the component base class. And this will tie it up together, and you can use continue to use any C# code that you put in the base class. So that's C# in Razor components for you. Let's talk about routing in Blazor. This is quite a fantastic topic in itself. In my GitHub repo, I've got a pages folder and my repo is based on the Blazor WASM model, but whatever code I have here is equally applicable to the server-side Blazor model as well. So if you look at any of the Razor components in my pages folder, you can see a page directive with a magic string at the top of it. So this suggests to Blazor that this component has a route. And when such component gets compiled and built, a route attribute is attached to the route to the component. And what I have here is put in as a route template. Now, the router component is a component that you would find in the app.razor, which is the root component of the Blazor app. So in here we have router. When the app boots up, this router component goes and scans the assembly that is specified in the app assembly, and it gathers the information about all components which has a route specified or a route attribute attached to them. When the user requests a URL from your app, router tries to find a match for the incoming URL in the assembly for the route attribute it's got knowledge of, and tries to find a match for the incoming URL. And when it finds a match, it passes the control over to the route view component along with any route data like parameters, and that gets served up to the end user. When the match is not found, it passes on the control to the not found component here, and that gets served as well. I've been playing around with it. It is slightly different in how the Visual Studio Blazor WASM template itself is. I've tried to play around and see whether I can have a layout view for not found here again. So that is routing in Blazor for you. Let's talk about parameters now. Parameters are an important way in which components can consume dynamic data and display dynamic information. It's also a method using which components can talk to each other. So let's talk about the two different types of parameters, which is route parameters and component parameters. So with route parameters, let's see how they work. So I've got a component here called parameters for my demo. And in my route template, I've got a route parameter specified like so. Let's just imagine that the question mark doesn't exist for a moment. And this is how you would specify a route parameter in your route template. So value is treated as a route parameter by Blazor. So when the information about the route in the route attributes or components in your app is gathered by the Blazor router, this is considered as a route parameter by the router. And this is how you specify a parameter. To consume a parameter, you define a public property of the same name as the parameter. It's a case insensitive match, but the names need to match. And you specify a parameter attribute for the property. And this is how you consume a parameter. Now, previously, before .NET 5, there was no concept of optional route parameter. Optional route parameter was introduced as a part of .NET 5, and the syntax for that is like so. So this marks value as an optional parameter, which means that even without a parameter specified in the incoming URL from the user, the app continues to work. The way it is consumed doesn't change. There's also a concept called route constraints, in which you can constrain the route parameters by a data type. So in this case, only if the ID parameter is confirming to the type int can the route be matched. Also, to consume that route parameter, you need to have a public property of the same data type as specified in my constraint. And of course, there's the parameter attribute. Let's have a look at how this works at the front end. So with my route component and parameters, I've got a little demo here. So I've hard-coded the navigation links with parameter values 2 and 3 here. And the last one doesn't contain any parameter values. As you can see here, again, I have not specified any value here, but the app still continues to work. If I change between the URLs here, the app still continues to work, and the parameter value gets displayed here because I'm displaying that value using my code like so. To show you the route constraints, I've got another link here. I'm passing in a value of 100. 100 confirms to an integer data type, so the page works. But if I change it to something else, which doesn't confirm to int, as you can see, it is throwing here for a 4 page not found. There is also the concept of catch-all parameters. Catch-all parameters can be useful if you want the parameter value to span like multiple folder structure, like today slash is slash the day of DDD 2020. So that is specified using a syntax like so here. Where is it? Catch-all. Yeah. So I've got the route template here, and that's the syntax for the route parameter to be treated as a catch-all parameter. You have an asterisk before the route parameter name. The way it is consumed still doesn't change. It's a public property of the same name with the parameter attribute. However, with the catch-all attributes, the route parameter needs to be at the end. It should be the last thing of the route template itself. So that is catch-all parameters for you. And to see it in action, I've got the catch-all route params here. I've got 2020/12/12, which is treated as the parameter value and gets displayed. We also have the concept of component parameters. And this is particularly useful when you have shared components. So in my code base, I've got a shared folder and I've got all my shared components here. So I've got this little display text shared component, and I am displaying some property values here based on a if check for the text parameter here. So I have a public property defined here called text, and I have the parameter attribute attached to it. Blazor treats this like a component parameter. This doesn't have a root, but it has got a parameter, so it is treated as a component parameter. When component parameters are defined for a component, when I use it in my parent component, so the parent component here is parameters because that's how I am calling my child component. I am calling the child component here called display text. The parameter which I just specified is available as an attribute on the component itself. So I can pass values here. So this is a good way of communicating from parent to child components. There's also the concept of cascading parameters. As the name suggests, it tries to catch something which cascades. So cascading parameters has two ends, a cascading value, which is the value which cascades, and cascading parameter, which receives the cascading value. A good example in the Microsoft Docs, what they say is about a theme or a CSS class, which you want to kind of spread across your entire app. If you start specifying component parameters in this instance where the CSS class should be available for all the child components, it can get quite clunky. So you start at the top level where you want that value to start propagating. In my instance, I wanted to start propagating at the main layout level. So I use a cascading value component for this. The cascading value can have a value and a name. The value is set to a field I've got here called shared text. It is of type string, and it's got a string value attached to it. I also specify a name for the cascading value for the called shared text name. At the receiving end, in my display text, I have a parameter or a field, a property specified called fallback test, and I have attached the cascading parameter value to it, and I give it the name shared text name. The reason being, cascading values and cascading parameters get matched up on the type. So I have a string here, and the value that is propagating is also string. But if you have multiple cascading values of the same type getting propagated, that won't work. So the name attribute kind of separates it out so that at the receiving end, I can specify which cascading value should I bind this field to. And hence I can have the fallback text displayed here. So that is cascading values and parameters. Let's talk about CSS isolation now. This is a new feature that was introduced in .NET 5. With CSS isolation, you can have isolated style sheets for your components. So if you have a component, say CSS isolation.tracer, you can specify a style sheet just for that component alone to override any global styles. Also, the CSS that you specify on your component, the isolated style sheet, doesn't affect any of the other components or take over any other component and apply the styles there. So let's see how that works. I have a CSS isolation.razor file here, which has got some markup. I need a isolated style sheet for this component, and that can be specified in the format, the name of the component .razor.css. And I've got a little style rule for the H3. So this style sheet gets only applied to CSS isolation. Every other H3 on the site will on the app, sorry, needs to continues to get the styles for the H3 from the global app.css for the Blazor app. So let's see this in action. By definition, I should see by H3 in green. It is doing that. Now, when you have isolated style sheets, only the markup on the page or only the component itself gets that style rules applied to it. If you want the child components of the component, the parent component in question to handle the style sheet or inherit the style rules that I have defined here, you need to add a deep combinator. So that is about CSS isolation. There's also the concept of CSS isolation bundling. When you have isolated style sheets in your CSS in your app, all such isolated style sheets are bundled up at build time to a file called yourprojectname.styles.css. So by definition, it should pick up the name of my project, blazor.wasm, and have .styles.css as the bundle name. Let's see whether that's happening. So if I look at the sources here, I can see this styles.css here. What happens is Blazor rewrites the CSS selectors to match the markup rendered by the component. So as you can see, it has re-returned something. It has got away with the deep combinator and added a unique kind of string to it. So this is called a scope identifier. It is a unique identifier for a component. It is of the format B-10 characters string. So this is unique for each component, and that gets attached to the style rules, and that is used to group the style declarations as well. So as you can see, my CSS isolation style sheet has this unique identifier. My main layout, which has got its own isolated style sheet, has this unique identifier as well. Along with this, the actual elements also get this unique identifier in the markup. So this is the H1 here. As you can see, it's got the unique identifier, and the div has also got the unique identifier here. So for the deep combinator to work, both the elements, like if you have an H3 in your child component, the child component as well as any other components must be the descendant of the same parent scope. So that's the reason I have added a div here, because the unique identifier, the scope, is attached to this div. And if both these elements are not the descendants of a same parent scope, then the deep combinator will not take effect, and hence any H3s in display text won't be highlighted green. So that's a catch with the deep combinator that you need to be aware of. If you have component libraries, and component libraries have Razor components which have got their isolated CSS, in my case, I've got one which I'm importing into this project solution. In such cases, the style sheet in that component library gets bundled into this format, a bundle.scp.css, and that is not available in my isolated style sheet bundle, but it is available as an import. So the name of the bundle takes the format, the component library name .bundle.scp.css, and it is available in the static WebAssets base path, which is always _content/ the library name for you. I'll leave you to have a look at the code yourself, but that is the basic concept around CSS isolation bundling with component libraries. Let's talk about life cycle of a component now. As developers, we all like to override and control the behavior of a component, and Blazor provides us with 3 or 4 different methods to control and override the behavior using some lifecycle events. The first lifecycle event to run for any component is the set parameters async. So this sets the parameters for the component. Let's have a look at the method signature for this lifecycle method. I've got this little child component here, which has got 3 component parameters: first name, last name, and job title. And on set parameters async, the method signature is here. It's an async task, so it returns a task and accepts a parameter view object. This parameter view object contains the value of all parameters that have been supplied to this little child component. I'm calling my child component from my parent component here, like so, passing in values for just first name and last name. Note that I have kept the job title untouched here. So when this lifecycle event runs, it finds a match for the first name and last name parameter alone in the parameter view object, and that gets set. The job title, which doesn't have a value incoming in the parameter view object, that is skipped. So let's have a look at the lifecycle event now. So as you can see, it's entering the set parameters async, and then the first name is bound and the last name is bound. So that is the set parameters async for you. The next lifecycle event to run is the on initialized, which has an async version as well. This happens on component initialization. So the first time a component is requested, this method kicks in, and it runs after the set parameters async always. The normal tasks I would do here is things like calling a database or an API to initialize my data on the app screen. And the method signature is a protected override void on initialized. And if you look at the console, it runs soon after the set parameters async. Now there's a catch around the on initialized method in Blazor server model because of the way the server model itself works, that is through a pre-rendering and a rendering, this method gets run twice. In Blazor WASM model, it runs only the first time the component is requested by the user. The third method to run is the on parameters set, which again has an async version. This runs after the component initialization, and then every time a parameter value changes, this method reruns. So upon the first request of the component, the on initialized runs. But if you have a change in parameters to the component, Blazor, being a SPA framework, treats it as the component just being requested with a new parameter. In such instances, the on initialized method doesn't run, but the set parameters async always runs, and then it straight away comes to on parameters set, and you can continue to do anything that you want after the parameters has been set there. So that's an important point to note around on initialized and on parameter set. The on after render, which again has an async version, is the last lifecycle method to run, and it runs after the component has been rendered completely. So you might have instances where you want to call JavaScript libraries from your C# code, which is again a cool feature of Blazor. In such instances, you need to wait until the DOM is completely ready for you. If you have child element references, you need that to be available before you can take any JavaScript actions. So all these DOM elements and child element references are available only for you at on after render, which is the correct place to do any calls to JavaScript libraries or even use child component references. Let's have a look at the method signatures for on parameters async and on after render. The on parameters set async returns a task, and I'm not particularly doing anything on it. The on after render async again returns a task, but it accepts a Boolean called first render. The first render is true only for the first time the component is initialized. If the parameters keep on changing, the first render becomes false the minute the first on initialized runs. So you can always check whether it is a first render before doing any calls to JavaScript or using child child element references. I've got an example of how JavaScript can be enabled from C# or JavaScript can be called from your C# code in Blazor. Feel free to have a look at the example here. And there's also extensive documentation on how that can be done in the core docs. Data binding, Blazor being a SPA framework, data binding is of utmost importance. Blazor supports one-way data binding, which is unidirectional flow of updates. A classic example would be to show a property name, a property value on a label. So if I have a property called property name, its value can be displayed on a label by using the syntax @property name. The most important thing to note with one-way data binding is that even if I'm interacting, say, using a button click, it is the system itself or the app itself which updates the value for me. I cannot control the value of what I'm updating myself. And this is quite clear from my example here. Data binding, there we go. I've got an example here where I have a current count field. The current count, I'm displaying the value here, and I have a button which upon click runs something. And in my increment count, I'm incrementing the value of current count. Now, when I go into my front-end app here, I'm interacting with this button, but the system is updating that value for me behind the scene. I'm only responsible for displaying it. That's the most important thing to note with one-way data binding. There's also two-way data binding, which is the lifeline of forms in Blazor. And all magic in Blazor around two-way data binding happens across the bind directive. The bind directive is specified on an HTML element like an input type text or a checkbox. And the bind directive is quite clever enough to understand which native attribute of the input control to bind to. So if you have an input type text, it knows it needs to bind the property name to the value field. If it is an input type checkbox, it knows it needs to bind the value of the expression to the checked field. So the bind attribute, the value of it can be a property name or a field name or even a razor expression. So let's have a look at how that is done in my little demo. I have a first name field here, and I am binding this input type text to the first name field here. By default, two-way data binding happens when the focus is lost, and on input type text that happens upon the on change event. So as a user, if I tab out of that field, I can see the name being bound. And to show you what happens, I'm also displaying the value here. Now I can override when that data binding happens by using a syntax like so. So I'm telling Blazor, hey, Blazor, bind the value for first name input for this text box upon the event on input. So in this instance, upon every keystroke that I make, the value gets bound, and that is displayed here. So let's have a look how that happens here. So currently I don't have any data bound, which is the reason you don't see anything. But as soon as I tab out, the data gets bound and I can see the value. In the second one, it gets interesting, as in when I type it, it calculates and does something. So that's two-way data binding for you. Event handling, you've seen some examples already, but events can be specified on HTML elements of the format on event. So if I have a button, I can specify an event handler for the click event using the syntax @onClick equals handle on click. You might have already seen the example here where I'm specifying an on-click event and specifying an event handler for the button. I can also pass in an optional event args into my event handler, like so, if I want to gather more information about what exactly happened. So I've got this second button here upon which I'm passing in a mouse event args. Let's see what gets written into the console. Let me get rid of this. So when I click, it is writing out to the console which mouse button was clicked. And by definition, 0 is the left button on the mouse. Event handlers can be asynchronous as well. So that's another point about event handlers. Having said that, there are a lot of built-in components in your Blazor app as well, starting with the app, which is a root component. You can have authentication and authorize views. You can have the main layout, which is another view, the nav link and the nav menu. They are again components. The router is a component, and virtualize, which was introduced as a part of .NET 5, again is one of the newer components in Blazor. Let's talk about forms now. Components are such an inherent part of Blazor apps that it is everywhere, and that's the reason why I've spent some time on components. But as you can see, forms also uses a component called edit form. This is the syntax for edit form. Edit form accepts a model, and you can pass in a view model to it, an instance of your view model class. It also has event handlers for valid and invalid submit. So upon a valid submit, that is if all your validations pass, on the form, the on valid submit event handler is called. Otherwise, the on invalid submit event handler is called. There's also a third on submit if you want to use custom code to trigger validation, etc. So let's have a look at how this is on my demo. To demo the forms today, I have got a contact form or a pretend contact form that I put together, and I've got a view model for that. So that's a contact form DTO. I have all the expected fields in a regular contact form, got a date of joining. I'm also capturing the favorite color and hobby of the person. I'm asking for some password just to show you an example of something. And I've also got a complex type called complex type property called personal address, which is of the type address DTO. And again, address DTO contains just address line and postcode. So looking at the form component itself, I've got it here. That's the edit form. I am passing in a model and specifying event handlers for on valid and invalid submit. So looking at the C# aspect of this code, that is my contact view model instance that I'm creating. And that's my event handlers for valid and invalid submits. So that's the form. But before we move on any further with the form, let's talk about some of the built-in form components as well. Blazor comes with a lot of built-in components ranging from input checkbox, date, file, number, radio group, select, text and text area. And they also have an equivalent of what it renders out as. The input file, input radio and input radio group was introduced as a part of .NET 5. If you want to gather more information about it, I highly recommend watching the .NET Conf session by Steve Sanderson and Safia Abdullah, where they go through each of this. A little bit more about the input components. They all support arbitrary attributes. So if you pass in any attribute like attribute 1 equals value 1, it does not error out. It gets gracefully rendered into the HTML. All these input forms support validation as well. So when the field state changes, it has the inherent ability to update the field CSS class as well, as you will shortly see. All the custom input components is built by inheriting from the input base of type T. So if you want to create your own custom components, you can do so by creating a class which inherits from input base of type T. With forms, validation is must. So let's have a look at how validations work in Blazor before we see a form in action. By default, validation is supported using data annotations in Blazor. So if you have done MVC previously, data annotations might be a topic which is familiar to you. But with Blazor, alongside data annotations, you also need what is called a validator. And it is the validator which actually attaches the validation support to data annotations. So this is a component which needs to be inside the edit form. Without this component, no matter what data annotations you have on your view model, the validations just won't kick in. So if you look at my form here, I have the data annotations validator here. There's also the validation summary, which summarizes the validation messages. Again, if you are familiar with MVC, you might have come across a validation summary in MVC as well. It performs, or it works in a very similar fashion. It summarizes the validation messages. You can also show validation messages on a per input basis, and that is achieved by a validation message component. So let's have a look at the form here. So as I explained, I have got this view model here with required on pretty much everything. With my favorite color and hobby, I want to show a radio button and a select list on the front end that is on my app. So I am passing in an enum of type color and hobby respectively. So I can loop through the values in the enum and build up my radio button list and select list from there. So in my edit form, I already have my data annotations validator. I also have my validation summary to summarize all my validation messages. I have the input text field for first name, last name, phone, and email. And as you can see, I am passing in the placeholder, which will gracefully get accepted. And I'm also passing in a non-existent attribute here to prove the point that it is not going to error out on the screen. And I have also got a validation message for the field. It takes a for attribute and takes an expression which binds itself to the contact form model first name field. Similarly, I have input text and validation messages for last name, phone, and email. I've got an input text area for the message. It's not a required field in the view model, so there is no validation around it. The date of joining is a date, and I've got an input date around it and a validation message. I've got an input number for age. I've got an input text again for password. I did some tinkering around it and found that you need to explicitly pass the type equals password for the text what I type in to get hidden. I don't know whether this is the right way of doing it or if there is a better way of doing it, but this seems to work for me. There is also the address line and postcode. They are required fields in the required properties, or it's marked required in the contact form view model, which is the reason why I've got validation messages for that too. That's the input radio group. So I am saying that all my input radios for color belongs to the same input radio group here. I've got a select, which is again built up from the enum for hobbies. And I've got a checkbox for accepted terms. Now, if I go and submit the form here and see, let's see what happens. So back to my home page where I'm going to go to the contact form and I submit the form here. Yay, I get the validation summary here and I have a per field validation basis here. If I look at the first name field, my attribute is getting rendered. It's not erroring out. It's picking up all the placeholders. The password field is required. I'm typing in something. The password attribute, the type equals password works for me. Now, if I type in something different, it might not validate properly. That's because I've got the data annotations for comparing the passwords. But I've got a problem here. The address line 1 and postcode, which are marked required in my nested property, nested object type, it just doesn't kick in. So this is a shortcoming of the data annotations validator, that it cannot validate complex types. It can validate only top level properties that are not collections. So a workaround which Microsoft suggests at this point is to use this experimental package. And this helps us validate the entire graph length of a model. And that can be done by installing the NuGet package. And once installed, it gives me an attribute called validate complex type. So if you have a complex type in your view model, it can be marked validate complex type, and data annotations for data annotations validation for this complex type also should kick in. But that's not enough. You need a validator for this as well. So if you swap the data annotations validator with the object graph data annotations validator, it should be able to show the messages on the front end as well. So feel free to have a go at this in your free time because this GitHub repo is public and I'll be sharing the links to it as well, but I'll have a look at it. I'll let you have a look at it. It's also important to understand the concept of edit context, field identifiers, and field state with forms in Blazor. Edit context, it is the metadata information holder. It holds information on which fields have been modified, their state, the validation messages for various fields, etc. The edit form component can accept either an edit context or a model. So you can pass in a model, or you can explicitly specify an edit context for the edit form. When you pass in the model, the edit form creates an edit context for you and manages that for you. But you can also create an edit context explicitly and pass that to your edit form. Let's have a look at how that is done. Got this example here where I am passing an edit context to the form. So with the edit context, the way I create it is I need to create a form view model which provides the basis for the edit context. And I specify a field for edit context, and upon on initialized of the component, I create an instance of edit context passing in the instance of my view model. This will tie up the edit form to this particular edit context, and it will start tracking the metadata among what fields have been modified, their state, validation messages, etc. for you. So with the complex property validations that I showed you earlier, a workaround that was suggested previously to use edit context to validate that complex types for you. But I thought it's relevant highlighting that package here, hence the reason. Edit context needs something called field identifiers, which are identifiers for a property in an object instance. It's using field identifiers that it tracks the state of a field, the validation messages attached to the field, etc. Field identifiers are specific to a property in an object instance. So it's quite different from reflection, because reflection relies on the class, whereas field identifiers relies on the object instance. So if you have two object instances of the same class, the same property will have different identifiers for both these instances. Blazor stores two key pieces of information as the field identifier. One is the direct reference to the object itself in question, and the second is the name of the property in that particular object. And these field identifiers are used to hold the field state, which is additional information about objects properties. So edit context has a private dictionary field which holds the field identifier and the field state, and it is then flattened out so that edit context can use that information for validation, etc. And where would I use edit context? So if I want to execute additional business logic based on validation, additional business logic validations, say I cannot have test, the word test in my email, or at any other business logic validation, that is a useful scenario where edit context can be used. You can create custom validator components, which does that task for you. You can also create custom validation class attributes, which is again a new feature that's been introduced with .NET 5. So let's see how we can create a custom validator component which does some validation against business logic for me. So the scenario I have got here is on my form here. On my form here, on my email, it shouldn't have the word test. So I am using a little bit of business logic to achieve that. But having said that, I can equally use custom validation attributes for this. But I just wanted to show you some code, which is the reason why I have taken this route. To create a custom validator component, you need to create a class which inherits from the component base. I specify a message store which maintains the list of all the form errors. The edit context of the form is available as a cascading value. So I am capturing it using a cascading parameter so that all my child components, that is input fields, selects, all of them have the edit context which can be shared. And upon the on initialized method, I create an object instance of the message store, and also I hook up to the events. So whenever a validation is requested or a field is changed, I am clearing out the message store here. Upon validation request, I'm completely clearing out the message store. But when a field is changed, so if I'm changing the field from valid to invalid or the other way, I clear the message store just for that field identifier. When I call the display errors method, which I've specified here from my code, it loops through any error messages for the particular, it loops through any error messages in the current edit context and adds it to the message store and notifies the edit context that validation state has changed. Similarly, if I call the clear errors from my code, it clears the message store completely and notify that the validation has changed. Now, how do I use it and hook it up to my form? For that, in my form, I have a custom validator suggested here. As I said earlier, having validations just won't help unless you add a validator in. So in my case, I am putting the validator in place. All this code is is taken from the core docs, so feel free to have a look at it. I also add a child element reference to my custom validator field, which I have specified here. So that's the custom validator field. Now, when I'm handling valid submit, because I want to make sure that the form is completely valid before I carry on with the business logic aspect of it, I clear the errors and I specify a new dictionary, and then I check the email field here, whether it has got a string test. And if it has the word test anywhere in the email, I add an error with the name of the email property in my view model as the key, and a list of string as the error messages, and it says cannot be a test email. And if there are errors, I am displaying the errors, which clears out the message store for me. Sorry, it doesn't clear. It adds to the message store for me and then notifies the current edit context that the state has changed. So let's see how this works. Let's make the form valid to begin with. So it is triggered indefinitely, and it's, as I said, a business logic validation to say that it cannot be a test email. And as I said, you can equally achieve this using a custom validation attribute, which is my next topic. If you have done MVC, again, this is a topic which is of which could be a familiarity to you. To create a custom validation attribute, I again create a class here which derives from validation attribute. So the scenario I have got here is I've got a date of joining here, which needs to be greater than 1965. So if the year of the date of joining is less than 1965, it errors out. So from the object value that comes in, I get the year, and if the year is less than 1965, I return back an error message along with the member name. So if I see this in the front end, this is how it triggers. So year cannot be before 1965, and this attribute is directly attached to your property in the view model, cannot be too old. So that's the attribute here for you. The last thing for the day is custom validation class, which is something that was introduced again in .NET 5. Sometimes you might want to override the out-of-the-box valid and invalid CSS classes, which highlights the fields for you, and have your own class. So it can be useful when you work with a framework like Bootstrap, which has got its own CSS classes for valid and invalid fields. And this is how you would do it. So every form or edit context has what is called a field CSS class provider. To create my own field CSS class provider, I create a class which inherits from the field CSS class provider and override the get field CSS class method. And I am passing in an edit context and the field identifier. And in my method, I check whether the edit context has any validation messages for the field identifier. And if it is valid, I'm returning valid good field, otherwise bad field. This is just me playing around so that I can still have the valid, which is the out of the box valid CSS class from Blazor, but just add my own field to it. This is not enough to tie up the field CSS class provider to my form here. I also need to attach it to my edit context, which I've done so. So as soon as I create my edit context instance, I am setting the field CSS class provider to use the instance of my custom validation CSS class. And in my app CSS, I've got some CSS around this. On good fields, it's outlined to green with a dotted format. On bad fields, which doesn't validate, it's outlined in maroon. So let's see whether the good fields and bad fields are kicking in. So the good field is working. As you can see, it's highlighted in dotted green. And of course, the bad field is working as well. It is in dotted maroon. So that is it from me today on components and forms in Blazor. These are some of the resources, and that is my GitHub repo. I will tweet that. And thank you for having me on board today. Let me see if there are any questions and see if I can answer some of them. Are you limited to one submit button per form? Maybe you can have multiple ones. I haven't tried it out myself, but I don't see a reason why. Okay, Dave S has asked me the considerations I would give to production use of Blazor for high traffic websites. Would I use WASM or server side for this? So, and what are the pros and cons? So I haven't deployed a Blazor app myself, but Blazor server model works on the basis of a SignalR connection, and Blazor WASM downloads all the dependencies to your own browser. So it is up to you what you want to do with it. So if you you can by all means host Blazor server as a Azure SignalR application, which is where it gets really performant, but then it is quite expensive and it needs to scale properly as well. So if you want a huge user base for your Blazor server app, the cost increases. With WASM, you can put it on a blob storage, and I have seen examples where demos have been put even on GitHub as GitHub pages. So it is up to you. It is up to you to weigh out what kind of application is it. Do you want to host it on the server? Do you want a huge user base for it? So it is based on some of those parameters that I would choose my model. How would you create shared component libraries? I have an example for this in my repo. I can create a component library here. I have one here called blazor.myComponentLibrary. It is a Razor component library project type, which I have added. It is just like any other project type. You get it up and you can share that within your organization, or even open source it up and spread to the wider developers in the developers out there. Dave is also asked me my thoughts on sharing models between front-end and back-end services if the types are identical. I don't really get your question here, but feel free to reach out to me on Twitter if you want, because I'm aware of the time as well. Thank you for having me on board, and that's it from me today.